Hello. Let's continue with gaining knowledge in physical sciences. Another session on chemical equilibrium. Very important section in chemistry. Question number 6 in the normal question paper. And let's gain more knowledge and more expertise and skills in this section. Technical knowledge for that matter. Question number 6 in this question paper. They're saying, consider the following hypothetical reaction reaching equilibrium in a 250 milliliter closed container. Remember, immediately when you see 250 milliliter, you must convert it. We don't work with milliliters here, we work with the cubic decimeter or liters. This will be now 0.25 decimeter cube or liters. Fine, so we'll be working with that one. So then in this case now we're given this one 2xO2 plus oxygen reversible to 2xO3. In this case the delta H is negative, meaning that it's exothermic. The activation energy for the forward and the reverse are 160 and 280 kilojoules. Yes, activation energy for the reverse must be bigger than the forward in an exothermic reaction. Fine. Now 6.1, define the term chemical equilibrium. 6.1. Remember, there are two ways of defining chemical equilibrium. You can define in terms of rates. Then we'll say now it's when the rate of the forward reaction, equal to the rate of the reverse reaction. So that's the first option, or when the forward reaction rate equals the reverse reaction rate. Or you can define in terms of concentration. Now it's when the concentrations is the state of reaction whereby the concentrations of the reactants and products remains the same. They are not equal, but they remain constant or remain the same or remain unchanged. That is 6.1. 6.2, they are saying to us, write down two conditions required in order for a chemical reaction to reach equilibrium. There are two. Remember, the first one is that the reaction must be reversible. A reversible reaction, and that reversible reaction must take place in a closed system. Fine. 6.3 in this case, now they say calculate the change in enthalpy for this reaction. Delta H, enthalpy change, remember is negative. It will be now 160 minus 280, which is the same as negative 120 kilojoules per mole. That will be the answer. 6.4. In 6.4 now they say initially a mass of 32 grams of unknown compound XO2 and 0.25 mole of O2 are sealed into an empty 250 container. We've already dealt with that. 250. When the chemical equilibrium is reached, it is found that the concentration of O2 is 0.25 and the equilibrium constant for the reaction is 36 at 50. Remember, we don't have to change the temperature. It has to remain 50 degrees. Remember, when you change temperature, the Kc will also change. Therefore, 6.4, is the reaction profitable or not? Give reason. So with the Kc of 36, the yes, the reaction will be profitable, yes. And then now why that is so, then it will be now simple that to say Kc is greater than 1 in this case, or you can say the concentration of the products, concentration of the products is higher than or greater than, greater than that of the reactants, I think that would be also the perfect one. Now 6.5, use suitable calculation to identify X 9 max. Now what do we do? In this case, once it's this many marks, we are going to draw the table. Let's look, just copy the reaction. First 2xO2 plus O2 forms a 2xO3. Fine. 2xO3. Fine. What we do, the best will be draw 5 lines. That's the best method. Draw 5 lines below. 3, 4, 5. Every substance must have its own column. Every substance must have its own column. And then this side we just leave to show the examiner that we are working with moles or concentration. So there's 2 methods, remember, mole method or concentration method. In this case I'm working with mole, the easiest one. Initial mole, change in mole, moles at equilibrium, and concentration at equilibrium. Fine. Let's check what is given. I can use a different color. I'm given in this case initially the mass of XO2, it's 32, so we don't work with mass. Let me just put X here, I don't know that. And then for O2 is 0.25. Fine. Nothing is said about the product. I will assume that is 0. Fine. At equilibrium, I'm given the concentration of O2. Concentration in line with O2 is 0.25. 0.25. Fine. Now with concentration, we're going to now, remember, multiply by volume. Multiply by 1/4. So if you multiply it by 1/4, you will get 0.0625. Now I started with this one. I don't know how much I've used, and then but I end up with this. Therefore I must have used 0.1875. You just say this one minus this, it will give you this, isn't it? Think you understand that. This will be negative, this will be positive. Now this one, because it's in the section where I'm using ratio, the ratio is 2:1:2. If this one is 1, what is double it? Then it will be now 0.375. And then also this will be the same as this one, 0.375. This will be 0.375. Then I divide by volume. It's the same as multiplying by 4. Then I get 1.5. This one, this minus this, it will be now X minus 0.375. I now divide by 1/4 is the same as multiply by 4. Therefore this will be 4x minus, in this case, 1,5. I hope it's understood in this case. Now from here I can now solve the problem. Yes, how do I solve the problem now? Then I just write the KC expression. KC expression for this equation in this case will be, you still remember this one, the products is only 1, therefore I'll have a concentration of XO3 squared divided by the reactants are 2, then it will be concentration of XO2 squared multiplied by the concentration of oxygen. For writing this one, we'll get 1 mark. Now I have to substitute. According to the question, Kc is 36. If you still remember, it's given here that Kc for this one is 36. Therefore, you write 36 equals to, and then now it's going to be a 1,5 squared divided by, this one will be now 4x minus 1,5 all squared into 0,25, the given one. Fine. If you work it out here, you will find that now the value of x, in this case, x will give us and this one, let me just, okay, let me make it simple. Therefore 4x minus 1,5 will give me 0,5. Therefore x will be the same as 0,5 mole. Now if I know the value of x, we go to the table. If I know this, if this one, the value of x is 0,5, therefore I can now determine, in this case, the molar mass, because I was given 32. Number of mole equals to given mass over the molar mass. I think we know the formula. 0,5 will be the same as 32 divided by m. Therefore m will be the same as 64 grams per mole. Fine, no problem. Once m is 64, then but now I need x. M, the molar mass of XO2 will be now the 64. Yes, 64. And then now, but I know that in this one, the molar mass, then it will be now x plus 16 times 2. X plus 16 times 2, which is this one, oxygen. 16 times 2 equals to 64. Therefore, the value of x will be 32 grams per mole. Then now I can conclude, if x is this one, therefore which one is having 32 in the periodic table? Therefore x is sulfur. X is sulfur, or you can just write S, capital letter S. That will give you the 9 marks. That was 9 marks in this case. We have identified element X. Now we move. We come to the last 2 questions. That is 6.6. 6.6. Now they say to us, the temperature of the reaction is now changed to 30 degrees. Remember, the equilibrium was at 50. Now we move to 30. What happens? It means that the temperature was decreased. What effect will this change have on the following, right? Increase, decrease, or remains the same? Remember that our reaction, if you look at our reaction, is exothermic. So if we decrease temperature, in essence, we are favoring the forward reaction. So the production of the products. So the concentration of this one, the concentration of this one will decrease, the concentration of this one will increase. Now fine. The first question, they say, what happens to the concentration of O2? As I've already explained, the concentration of both of the reactions will decrease because we are favoring the forward. Then the answer will say decrease. Fine. The last one, which is 6.6.2, fine. What will happen to the value of the equilibrium constant? Explain your answer. Kc value, because when we decrease the temperature, we are favoring the forward. The concentration of the products increase, that of the reactants decrease. So it means that the Kc value, in this case, Kc value will increase. Yes. Why? The reason will be now. Forward reaction is favored by decreasing temperature. Forward, or let's write the principle: decrease in temperature. Decrease in temperature favors an exothermic reaction. Therefore, forward reaction will be favored. Forward reaction is favored. Or you can just say the concentration of the products increases in this case. So, and that of the reactants decreases. I think that is an alternative one, but otherwise the easiest one would be in the method of principle. As we decrease temperature, an exothermic reaction is favored. Which one is exothermic? According to this given equation, is the forward reaction. So the forward reaction was favored by, in that case, by decreasing the temperature. Those will be the simple answers. I think we are gaining more and more knowledge in this. So until we meet again in the next section, don't forget to subscribe. Don't forget to keep practicing. Little information is very dangerous, so make sure that you are more exposed. Answer this question from different angles. This was one typical good question. So where Kc is given, that's the bottom top calculation part. So to know both ways, they can be given moles, whatever, and calculate the Kc, or it can be given Kc and now go up. So that's how we do it. So otherwise, thanks a lot. And remember, in this one, so there are many ways. Some people can just say x and say 32/m. That is also correct. You work with 32/m, and this one now would be 128 divided by m minus 1.5. So you will still get the same answer, 128/m minus 1.5. You will still get the same answer. Or other learners can say, no problem, I'm not given this, I can just not write anything here. So you first calculate the concentration of XO2 at equilibrium. Once you find that concentration, now you multiply by volume to get this one. After you multiply by volume to get this one, then now you can say this one plus this will give you this. So there are many ways of dealing with this question. So it depends from the angle that you understand it from. So thanks a lot. Until the next session. Bye for now.